Hello, everyone. Good morning, good afternoon, wherever you are in the world. Thank you for joining the webinar today. There's a WBBA webinar, World Broadband Association webinar. The topic is AI for Net 5.5G and industry best practices. My name is Samir Malik. I'm working as a senior principal analyst and a lead global consultant for service provider routing and switching networks in Omdia, Australia. Today, I have a privilege of having seasoned industry technologists with me today in this webinar, and they have found time to share their thoughts on industry best practices and Net 5.5G networks infrastructure. We have today Dr. Tayeb bin MERIEM. He is the IPv6 forum vice president and also leading the working group in WBBA for network technology and infrastructure architecture. Thank you, Dr. Tayeb, for being with us today. Then we have Dr. Chen. He is a senior network and chief architect for China Telecom based in Shanghai, China. He is the leading chief architect who is actually leading a team for China Telecom in China. And you know, the China Telecom is one of the big operator around the world and for sure in Asia. So thank you, Mr. Chen, for being with today for this webinar and taking your time out. Then we have Mr. Mehmet Durmus. He is a director for IP MPLS and network architecture in Turkcell in Turkey, Istanbul. I think his presence is one of the importance for this webinar because he's sharing a real insights about his network intelligence from connectivity to intelligence and talking about that how they designed IP MPLS network and using Net 5.5G in the network architecture for the Turkcell in Turkey. So thank you very much, Mr. Mehmet. And then last but not the least, we have Mr. Bram. He is a lead architect network infrastructure for Swisscom in Switzerland. But due to some personal commitment and family issues, he's not unable to come today. But he's recorded his session for this exclusive webinar about his insights on the Swisscom. So again, thanks from Mr. Biram. So this is all the introductions for the panelists and then the seasoned technology industrialists in this webinar for joining us in the webinar. And then they can speak on their turn whenever I can ask them to give the presentation. So I'm the moderator. I'm also doing the moderation for this webinar as well. In this webinar, we are covering 5 topics. WBBA Working Group 4 Framework and Achievements. Dr. Tayeb will present about the overall achievements and framework that what we have achieved so far from the flagship program of the WBBA Working Group 4. Working Group 4 is one of the network technology architecture group under the WBBA. Then we have AI for Net 5.5G and Net 5.5G for AI. I will present this topic from my side and my insights on that one. Then third, we have architecture evolution of China Telecom cloud network towards the AI era. So for this, Dr. Chen Zhonghua can present the China Telecom viewpoint on the cloud network infrastructure in the AI era. Then we have the fourth topic that Mr. Mehmet will present from connectivity to intelligence, and he will share the Net 5.5G practices in Turkcell and how they achieve the intelligence starting from the connectivity and how he achieved the journey of IP MPLS network design in their Turkcell network. And then last, we have a Swisscom based in Switzerland, everyone knows, the tier 1 service provider, and he's talking about the network transformation towards segment routing or SRv6, secure SD-WAN and CI/CD interfaces, and how they can achieve the network transformation and modernization for AI era. So these are the topics of today's webinar. You guys are more than welcome to ask any questions on your right side of your chat window. You can just write down the questions, and we are more than happy to answer your questions at the end of the webinar. And then we can share as per your requirements and what your expectations from the webinar and then technology. So this is the overall introduction for the panelists and then the contents of this webinar. Now I would like to invite Dr. Tayeb MERIEM, who is the IPv6 Vice President and also chairing the Working Group 4 in World Broadband Association, to share his insights about the working of Working Group 4 framework and achievements. So over to Dr. Tayeb for his presentation.
Oh, thank you,
Okay.
Samir. Hi, everybody. So the purpose of my talk is to share with you WBBA Working Group 4. It is a multi-stakeholder platform addressing network technologies evolution from both innovation and deployment perspective. It is the place for debating crucial broadband industry challenges to shape the network of future. So we are not looking at cloud and network in silo manner. Rather, we are looking at these two domains or two network in collaborative manner. So we are business and technical oriented body. Our mission is to help demand side and supply side interacting and transacting in the business assurance space to create and share value at the touch point. As you may know, in all organization or partnership, and we share information at touch point, and this touch point becomes a monetization point. We create big cake, and then we share the value between all involved parties in the ecosystem. We are not a standard maker. However, we select mature standard as foundation of our activities. Then we digest all these standards and we look at their applicability. What does this mean? That means we try to derive design blueprint and also frameworks and business scenario as meta model. And then we associate this framework into actionable framework as white paper series. That is our way of development of white papers. So our focus is on network evolution for 5G advanced in AI era. As foundation of 6G, we named Net5.5G. So we are looking at Horizon 2030 and beyond. Our white paper series try to answer two major questions from industry perspective. The first one is how to address 10 gigabit access requirement to consumer, to the home, to business, and to campus. And second major question is how to address future video application in the immersive experience, so-called metaverse. And also, we are looking at a new AI application or AI-based application. Both categories of application are expected to generate a large portion of traffic by 2030 and beyond, according to some forecast. This is the reason why operators need to rethink, redesign, re-architect, and update their IP transport network. For instance, metro network needs to be upgraded to 400 GE, backbone to 400, even to 800 GE, and data center will be upgraded to 8 GE, even to 1.6T, because we need to meet the requirements related to AI training model that consume large bandwidth. And besides, converged cloud and IP transport network need to introduce seamlessly as RV6 capabilities that transform the network in huge computer. And that is major shift. We inject at input instruction like computer, and then this instruction is like intent, and the computer or the network will behave as intent handler and intent executor. And that is very important because we need also, thanks to this SRv6, to unify the protocol. As you may know, we have diversity of protocol. In the backbone, we have MPLS, we have EV, stack of protocol, MPLS, RSVP, LDP, and in data center, we have another protocol so-called VX9, as you may know, and we need to achieve end-to-end continuity of the protocol crossing all these domains. And the good solution and the viable solution is a SRv6 protocol that offer this end-to-end continuity crossing all the domain. That is very important. Let me share. So working group number 4 is activities is articulated around what we named toolkit that we put together here in order to shape all the foundation of our activities from vision to standardization. And by the way, it's what industry expecting. The industry expecting the whole package, all toolkit that shape the value chain and value proposition. So we're starting from the vision to business scenario and use cases. Then we capture functional and non-functional requirements. That's very important. We are not looking at only at technical capabilities, but also we are trying to capture non-functional requirements. And then we are looking at the role of actor and their responsible demarcations. And then we provide design, blueprint, architecture framework, and the POC program that is very specific to our working group. Then we collect best practices from our members, and we provide them with deployment guide and certification in order to assess the viability of our papers. So zooming on building block number 7, that is proof of concept. It is very important because beside work item track that is the host of development of our white paper 3, we created this POC program to host project, POC project that can be submitted by our members. And the goal is to assess the viability of the concept of scenario of a business model that you have been defining our white paper in order to make sure that we are defining concepts that are aligned with industry need. That is very important. And during this proof of concept process, we can identify some gaps, and then we need to bridge this gap either by updating our white paper, or if the gap is so huge, then we created dedicated work item in order to bridge the gap and solve the issue. And it may happen that in some cases, this gap may impact standardization or specification. That is the foundation of our activities. As I mentioned earlier, we are relying on material standard. We are not standard maker. We are relying on standards that has been defined, and then we look at their applicability. And then if there is issue that emerged from our activity in our program, then we synchronize with the standards makers in order to update this standard if needed. It is like what LLM inference optimization process did with reinforcement learning of human feedback. We have this prospective analysis, feedback collection, and then we improve our deliverable by adding or updating our white paper based on the feedback. It's exactly the similar process for this LLM influence optimization process with reinforcement learning from human feedback. So let's move to the main takeaways and outcome that emerged from last 2 years' activities in working group number 4. In our activities in track number 1 for development white paper, we published 3 white paper, 3 deliverable, one on architecture, another one on best practices, and the third one on ER for Net5.5G. And we are developing another white paper on readiness assessment and certification. That is very important because we need to build trust and confidence on our published white papers. And for this typical white paper, we are collaborating and liaising with IPv6 forum because our Net5.5 architecture is SRv6 native, and we need to certify this part. And the best way to do that is to involve independent certifier, and IPv6 forum is bringing 2 framework, one on this IPv6 logo program, and second one on SRv6 logo program, and we'll be using both framework in order to assess the viability of SRv6 implementation in our white papers. And by the way, we also use this instrument from IPv6 forum, IPv6 logo program, in order to test and certify the product and solution that our members are contributing in our white paper. So from POC program side, we published 3 white paper. The first one is the proof of concept program framework. It's guide our project teams, members in the way they develop this POC program on the POC project. They can find various input and various documents, test plan, test suite, test series, and a set of template, test design, test execution, test report. All these instruments are helpful and support our member when they submit POC project. And we instantiate this POC program framework onto 2 real proof of concept project. The first one is Cloud XR video on demand that has been, it was 12 months project that we demonstrated and showcased in real and commercial network from China Telecom in 2 platforms. The first one in Beijing and second platform in Shanghai. It was a very important project. And second proof of concept project is was in collaboration with GSMA on voice or Wi-Fi end-to-end QoS. So that is very important to mention. Then we have also another activities related to what so-called pioneer program. Our pioneer program is collections of best case studies that has been contributed by our member, and we created a repository of case studies. We named a knowledge plane to share best practices, success story with all members in order to have this collective community using this asset. So far, we have 22 case studies from 10 countries covering the 5 continents. And this pioneer program is broken down in 3 categories. We have visionary pioneers, we have cities or region pioneers, and we have business pioneers, businessmen, operators, and enterprises that develop Net5.5G experiences and deployment. And these serve various purposes, as I mentioned here. So this year we published two major white papers. The first one is this proof of concept test result on 5G voice over Wi-Fi in collaboration with GSMA. The second one is ER for Net5.5G. And the way to develop this white paper, we are using our toolkit as foundation. And for this particular white paper, it's not a new white paper. Rather, we are using the component number 6 as proof ground and playground in order to add AI capability in all components of Net5.5 architecture in order to make it AI ready. From two paradigms, the first one on AI for Net5.5G, and second one is Net5.5G for AI. This is the major topic that is shaping our webinar of today. Thank you for your listening, and I give back the floor to Samir.
Yeah. Thank you very much, Dr. Tayeb. Thanks for presenting. I think I just try to summarize what Mr. Tayeb already mentioned, that WBBA is not a standard organization, but is basically a industry best collaboration of vendors and service providers in modernizing the IP datacom network in the AI era, and then so and forward in certifying their best practices in the world. And that's the reason we are writing a white paper, technology insights, every year, around one or two white papers, and then publishing in Mobile World Congress and then industry forum. So that's a summary. And you are more than welcome to ask questions in the chat window so we can answer in the end of the webinar. So second topic is AI for Net5.5G and Net5.5G for AI. That's I'm going to present a very quick one from my side. This is basically the white paper that we already published in NetworkX in October, early first week of October. Is AI for Net5.5G and Net5.5G for AI. You can log into WBBA.com websites and you can register and free download the learning material and resources, these white papers with the registrations. And this white paper actually helps you with more, service providers and ISPs and government and regulators in this webinar. And it actually helps you to find out the foundational architecture of Net5.5G. Like it's similarly the same thing like in wireless network, we talk about 4G, 5G, 6G. So in fixed network, it's always a missing puzzle that where is modernization or some generations for network modernization, for especially for IP datacom transport network. So for that one, Net5.5G is basically a foundational architecture. We wrote first white paper before this is about the overall Net5.5G, and then in this one only focusing on using the AI in Net5.5G. So if I can go to the next slide, before I can show you the difference of AI for Net5.5G or Net5.5G, what it is, the most important thing from my side as an analyst from the routing and switching network, I would like to share that the total of 3,850 exabytes of data will be expected in 2033. So you can imagine the next coming 6-7 years will be very AI heavy future for all over the world, not only for telcos. So our forecast is for that the projected growth for AI and non-AI network traffic in 2033 will reach around approximately 3,850 exabytes per month, which is 6.6 times growth as compared to 2025, that what we are sitting in this year. And then you cannot imagine that the next 6-7 is not, simple conventional traffic, but is more on AI enhanced traffic or purely AI traffic. So when we talk about enhanced traffic, is like intelligent integration of AI in existing services at home, business, or 2B, 2C, or 2S services, and then a purely, completely new AI services that we never think of today. Maybe something purely that needs and run on the AI platform, or AI required the AI capabilities, not like simple chat GPT or DeepSeek or simple agentic models, but maybe more advanced than that. For that one, the question is always in the mind for service providers or telcos that are we good enough? Our network is ready to carry these AI workloads or not? So that's a question mark. So, I mean, we based on this forecast, based on this trending and industry study analysis, we came to this two network infrastructure. I think that's the most important. On the left side is basically Net5.5G architecture release one that we publish in Mobile World Congress 2025 white paper, and you can register and download from WBBA website, that talks about how we modernize the IP transport network from the campus, access, metro aggregation, all the way to core backbone and then data center interconnect. Or some people call it data center network as well, but it's basically a data center interconnect network. And what about the bandwidth evolution? What about the incremental bandwidth requirements for access, like 100G for the access, or is using a 25 gig in access ring, then 400G for metro aggregation, and then 400 and slash 800G for the IP core and the backbone, if you can see on the right side, and then it how connects with the data center network, because the most of the AI is actually happening in a data center, not in the edge. I believe edge compute is the next step. So our data center networks are ready enough to carry the traffic between one data center to another data center inside one room or in a geo redundancy built outs. So that's basically, you can see from the left side, the picture release one is basically a complete end-to-end modernization picture, or the foundational architecture of IP transport network. That I think we are having a missing from standard bodies, correct me if I'm wrong, from last many years, because they talk about on bits and bytes in pieces like, okay, we can enlarge the access, we can enlarge the metro, but we're not talking about end-to-end network framework. So based on that one, when we feel that AI is everywhere and everyone is talking about, so we decided in a working group 4 in WBBA to go and write it down, the AI for Net 5.5G and how the Net 5.5G can helps to modernize the AI service flow. So on my right side of, or on your right side of the picture is called AI wrapper concept. So it basically is based on the complete same foundational Net 5.5G architecture, but it actually wrapped up, or it gets encapsulated with AI frameworks. So AI for campus, AI for access, AI for metro aggregation, that we call it a cloud network integration, and AI for IP backbone, and then AI for DCI. And on top of it, how we can leverage the AI, not simply the intent, but AI, digital twin, visualize mapping of the whole IP network to manage and orchestrate my IP network routers from bottom up approach by using telemetry controls. So if you can see, I know it's a bit smaller in this webinar, but if when you download the complete white paper, you can have a better view that we have the AI domains. So domains are AI campus, AI WAN network, AI DCN network, AI operation and maintenance, and then a base of AI use cases. So first we find out what are the use cases are for AI, and on base of that one, we actually modernize different AI domains in this network infrastructure. And then when we decided on that one as a big group in working group 4 of combination of service providers and vendors, then we found out, okay, what we need to do. So we need to build AI powered IP WAN network. That's a very important thing. Or in other words, some people call it AI powered or AI enabled IP transport network. So we need connections that should be AI supported. We call it AI connections. We have AI routers. We have routers for many years, but now the routers should be AI enabled. That can, they can do the packet transportation based on the SR native or segment routing native transportation from end to end, and then should be, I mean, having an agile experience. And then how about after the AI connection, how the AI went, and what about the AI operation and maintenance? So this basically the green part in my release 2 of Net 5.5G that is latestly released in first week of October, that talks about the same foundation infrastructure and but with the AI reference. And then many service providers already appreciated, who actually attended the Network X in Paris, and they said that that's really a missing puzzle for the fixed network or the wireline network for network modernization. And we are not saying that this is the end of the journey, but we are still working and brainstorming with the help of China Telecom, Turkcell, Swisscom, many other vendors in the industry, and find out that how we can make it more enhanced and more enlarged that can cover the tier one, tier two, and tier three service providers and ISPs as well. So I think that's I believe myself as an analyst and co-chairing with Mr. Tayeb. I think that's a good one to lead this IP transportation modernization. And then next step, we are planning to make it a best practices and certification sort of a process where we can see all over the world which service providers are using Net5.5G and how much they're successful. We're not expecting they're getting 100%, but to what extent they have benefited or leveraged this foundation architecture. So, long story short, this is the overall uh, uh, my summary of my presentation using the AI for Net 5.5. And we are more than happy to answer and during this webinar or at end of the webinar through emails or your comments. So now I am moving to my next uh, speaker and then a very distinguished chief uh, architect for the China Telecom. I think that's the best opportunity for you as well in the webinar to ask questions on China Telecom because it's one of the top 5 in the world. How they are using the cloud network integration in IP network for metro aggregation and then using moving towards the AI era. So over to Dr. Chen and
Okay.
he can explain his part. Thank you very much.
Okay. Thank you, Sammy. Okay. Hello, everyone. My name is Zhonghua Chen from China Telecom. It's my pleasure to have a presentation on the network development in the AI era today. Okay. First of all, I needed to share some background situation of the China Telecom's network with the development over the past several years. China Telecom has involved the traditional IP network into spine leaf-based cloud network convergence architecture by introducing some technologies just like the SRv6 and AVPN. Through this architecture, we can regard each region network node as a cloud network, as a local cloud, and interconnect these clouds via the new metro network. At the same time, each man is also regarded as a logical cloud, which are interconnected with our bare network. So under this architecture, to meet the development requirements of the AI era, we have organized the computing power resource pools in different regions and form the computing power nodes as different layers. Yeah, this is similar to the cloud nodes in the architecture. So in the diagram, we set up the local cloud, computing power centers and the supercomputing power centers, which represent the networking of computing power resource pools at different network levels. So in addition to the networking of resource pools, the resource management platform is the core element of the entire computing power architecture. So it's realized the registration of computing power resource and the status awareness, include the resource scheduling, forwarding routing, and the traffic optimization. So today we have two cases that fully demonstrate the functions of this platform. Of course, moreover, this platform itself achieves the automatic scheduling function based on the AI models. Okay, the first case is AI for network. We achieved the computing power leasing services on the new architecture. So we adopted a new network architecture to integrate the computing power resources of providers in Western China and provide a service to our customers across the country. There are mainly three core business requirements. The first one is integrating computing resource distributing in different regions. And the second is we also need to schedule computing and network resources dynamically. The last one is providing computing resources to users on a rental. Therefore, we divided the business requirements into two categories. One is the type of business with higher real-time requirements and large data volumes. And the other is the type of business with the complex competition requirements, but just with small data volumes. So the resource management platform will schedule these two types of business to different resource pools, such as the first type of business will be scheduled to the nearest computing resource. This not only reduce the network latency, but also save the end-to-end bandwidth of the network. So all of this will meet the requirements of low latency and high bandwidth the business requirements. So in the case, just like the 3D rendering business in this case, the other type of business can be scaled to computing power resource pools in more distant areas. Generally, these pools have more idle resources and can meet the demands of complex, maybe complex algorithms, computations. In these cases, the resource management platform will locate these resource pools from the backend database and push the routing information and network optimizing strategies to the network edge devices at that moment, so that the device will guide the user's applications to access these computing power resources. In summary, through computing power discovery and the optimizing of computing power routing, we have successfully realized the integration of computing power resources in Western China. Moreover, by means of intelligent scheduling, we have achieved national wide coverage of computing power leasing service. So next case is network for AI, enabling intensive AI training services. In this case, we got three key needs. A single data center may lacks enough computing powers to meet the AI training requirements. And maybe they will have fragmented computing power needs integration, and the small computing units may be combined into a large one that can support the AI training. To solve this, we built a distributed lossless intelligent computing network based on our new architecture. We have adopted the IP optical collaborator technologies to achieve extremely low latency, extremely high bandwidth, and the ultra high reliability. There are all essential network requirements in distributed AI training. On the other hand, automatic service management allows the network to set up, adjust, or remove the AI training service automatically. There's no need for manual configuration when you want to start a new training task or scale up or scale down the resource. So based on the architecture, we realized the world's first 800G based wild area intelligent computing test network, achieving over 97% of single data center training performance for models like Bram AI model. It also delivers the world's first cross data center training commercial cases, developed by the Bram Intelligence Company and the Tianyi Cloud Company. This solution also offers a low-cost approach for intelligent computing infrastructure. So in summary, China Telecom's cloud network evolution architecture and these two cases illustrate a clear mission to build a flexible, powerful, and cost-effective infrastructure for the AI era, where the unified distribution, the resource, offering on-demand computing power, or enabling larger-scale AI training. These innovations are driving widespread AI adopted across the industry. So I think that's all for my speech. Thank you for your time. Hi, Sammy.
Thank you,
I will
Dr.
hand it
Chen.
back to you.
Yeah, thank you very much, Dr. Chen. I think the one summary for your presentation is that I agree with you that lossless intelligent computing network is the fundamental for extensive AI training services now and in coming 3 to 4 years of the future for all the AI applications. And that makes sense. And we learn from China Telecom. They are so proactive and aggressive in making lossless intelligent network for AI trainings. So thank you very much for your time. And now I want to invite my next speaker, Mr. Mehmet. He is from Turkcell and he's talking about the connectivity to intelligence and he's sharing his viewpoint and best practices, how he's leading the team in Turkcell in modernizing their data IP MPLS core network infrastructure by using Net5.5G and then overall requirements of the network. So over to Mr. Mehmet Durmus. Thank you very much.
Thank you. Hello, everyone. It's a great opportunity for us to share our studies and experience, how we are preparing our IP MPLS network for the future, for the future services as well. So first of all, let me give some short introduction about Turkcell. Turkcell is a digital operator headquartered in Turkey, serving its customer with a unique portfolio of digital services, digital business solutions, and regular voice data and instant messaging services through its mobile and fixed networks. We are serving both mobile and fixed customers and also enterprise and wholesale customers as well. So actually, our IP MPLS network is multi-layer, multi-vendor, but single network. So it means we are collecting all different kind of access, mobile, fixed, enterprise, and wholesale. And also, we are connecting all core networks, core networks, fixed voice core, mobile voice core, and packet core as well. And also, we are connecting data center networks, and also some digital services such as IPTV services, for example. So today's IP networks has a very critical role as they connect all user access, including mobile, fixed, and wholesale, and enterprise, and all different kind of services, data streaming, voice. Actually, AI, ML, 5G, 6G, IoT, edge computing, and cloud are the key trends that are shaping the future of our IP networks. And at this point, ultra broadband, low latency, huge number of connections, autonomous networks, and security are the key characteristic of the scalable, stable, secure, and user and service-centric IP networks. So we are preparing our IP networks for the future to meet all these demands and requirements, actually. What we are doing to prepare our IP networks for the future services. First of all, I want to tell something about our SRv6 studies in our network. Actually, for the first contact with the SRv6 in our network, we established a trial setup between the two sites with the different vendors and performed EVPN test over SRv6. That was the first study we met with SRv6 and we experienced and we learned. And secondly, with another our valuable vendor, we have tested SRv6 and EVPN over 800 gigabit Ethernet connection. So that was the first study in the world, including SRv6 and 800 gigabit Ethernet together. Currently we are building multi-vendor pilot or trial network that will simulate our network, entire network, and all our use cases in this trial network. Actually, it's not trial network. It will be part of our line network. We will test all our services and use cases, and we will see the result, especially interoperability between the different vendors. As I told you before at the beginning of my presentation, our network, IP/MPLS network, is a multi-layer, multi-vendor, but single network. So we are working with most of the big vendors in the world. So it's important for us to test SRv6 and its capabilities between the different products, different vendors. Actually, in our IP/MPLS backbone network, we need EVPN for the service chaining, because we are carrying all different kind of services and traffic in our single network. So it is important for us to see how EVPN is working together with SRv6 for the service chaining for our different services. And TLFA for the first convergence, it's another critical feature for us. So because our network, IP/MPLS network, is really very big, we have more than 10,000 routers and switches in our network. So especially in core IP/MPLS core network, fast convergence is very critical for us, because we have to provide different kind of services with their needs. So the current fast convergence technologies are not enough to provide all these needs, and we believe TLFA with SRv6 will provide our needs for the first convergence. And another important point here is to have autonomous network. We will testing different controllers for centralized management, because if we to have an autonomous network, we need centralized management and centralized controllers. This is the last one, is our current topology and current study. Actually, our aim to have a live deployment, live SRv6 deployment in our network at the beginning of 2027. Right now, we are converting our route reflector topology in our network, because route reflectors are very critical, especially for the EVPN, together with the SRv6. Actually, we have just started to transform our network for the SRv6. I am going to share three current study for AI for network and network for AI. Actually, the first one, we have already tested one of our valuable vendors, AI1 product of one of our valuable vendors. And in this study, actually, we carried RDMA traffic between different data centers located, distance is more than 120 kilometers. Under the overload conditions, actually. Then we were able to carry AI traffic without packet loss using a subscriber priority-based flow control mechanism. This is very critical for us, because in current networks, it is not difficult, or it's not challenging to carry AI traffic inside the data centers. But if you need to carry AI traffic between the data centers, so the packet loss is very critical, because if you have a 1% packet loss, your throughput is decreasing more than 50%. So we need different kind of capabilities to carry RDMA traffics, AI traffics without any packet loss. In our studies, in our test, we have observed that if we don't use SPFC and our throughput decreased from 100 to 50 megabit per second. So we lose half of the total throughput actually. And when we used SPFC, and we experienced that our throughput was just approximately 90 megabit per second. In our second use cases, actually, we used some dynamic load balancing features of the new AI-based routers. And actually, we had three different sources and different bandwidth. And when we don't use AFR, so it is not possible to share these total traffic equally on the different links between the data centers. But when we used AFR, adaptive low repeating features, we observed that we could share the total traffic equally between the different links. So it's a very good feature to have a equal load balancing, dynamic load balancing between the different links between data centers actually. Our third case is about the green network. Actually, sustainability is one of our most critical focus because we have initiatives in Turkey, and we have two critical dates for us. The first one is 2030, and we will provide our all energy from the renewable resources actually, and we aim to have a carbon zero aim by 2050. So by using SFU dynamic sleep algorithm, actually we got a 10% power saving, especially in low traffic time. This is not any manual configuration or manual operation, just it's based on AI features actually. The system is calculating itself the traffic patterns, and based on this, it's a learning mechanism actually, and based on this learning mechanism, it is arranging resources inside the routers. So it's another valuable study and feature for us. Actually, this is the last point of my presentation. As a result, maybe summary, SRv6 is the key to prepare our IP MPLS backbone and network for the future. It's key for AI for network, also network for AI capabilities. We will have a tough target, especially for 2027. We aim to deploy SRv6 in our all network, live network in 2027. Thank you for your listening.
Okay, thank you very much, Mehmet. Thanks for sharing AI-powered network modernization for Turkcell. Though we are running out of time, but your presentation was very comprehensive, and I've seen there's a question as well for Turkcell, so we can answer later on. And now the last presenter is not with us, but he already recorded the session for Swisscom network transformation towards SRv6. So we can have a quick video recording for the Swisscom network transformation presentation. Then we go back to the question and answers. Thank you very much.
Thank you.
Okay, good morning, everyone. My name is Bram van Zwet. I'm the lead architect in Swisscom for our network transformation. And I thank you for your interest in what we're doing. to explain our network transformation, it's best to start with where we came from, how our legacy network looked like. And this is depicted on this first slide. You basically see here 3 columns. On the left side, this is more or less the B2B domain, where we built dedicated, or we have built dedicated networks for B2B, for the B2B market. In the middle, it's the mass market, so it's basically the residential and wholesale market. And then on the right side, we have the mobile domain. In the past, we explicitly decided not to converge the networks. Why was that? Because, for instance, our mobile colleagues, they are very keen on winning benchmark tests in our local market. And for that, they had to implement specific services directly into the network elements. On the other side, then we had the B2B market, where we may just have won another contract with a large corporate customer that also has its specifics and wanted to have their specific services implemented into that routing infrastructure. And that didn't fit together. So to provide the best services, we had decided to build different dedicated networks. In the past, that worked well, as long as you have mobile services on mobile networks and B2B services on B2B networks. But as soon as the whole service convergence came, we got into a situation where we basically had all services on all kinds of networks. And that was where things became complex. So our way out there is depicted on the next slide, where we said we have to decouple the services we provide, the network service, from the network infrastructure. So how we do that? Let me explain that in the B2B domain. All these service-specific configurations for that specific customer, we take out, we cloudify that, we virtualize that, and put it into our telco cloud. And the same we do in the mobile domain, where we take these mobile network service functions, we virtualize them, and also put them in the telco cloud. What remains then into your network infrastructure, your IP infrastructure, is basic transport, connectivity between, in the mobile domain, your mobile sites and your mobile core, or in the B2B domain, between your customer premises and the networks, or the data center networks where the services are located. And with that, we became to a standardization of services. So from there on, we could start building a consolidated network, which we have called Titan. You see that depicted on the right side. We have a single data center network interconnection infrastructure. We have, and that's a bit typical, not one core, but 2 core networks. The reason for that was that we said, yeah, in the end, your most vulnerable part in your network is the core. And to prevent against epidemic failures, we decided to share the load between 2 core networks. Both core networks are not aware of each other's existence. And as soon as we would have some problems in one of the core networks, we could isolate that and directly switch over all the traffic to the other core network. And with that, aim for the highest availability in our network. With this transformation, we have put emphasis on a couple of things. First of all, standardization of your portfolio. What we provide here as underlay transport is basically VPN services in 2 flavors: layer 2 VPNs, layer 3 VPNs. That's the only service we provide with the network. You can get them via an automated API. That API is available for internal divisions in Swisscom to build mobile networks or B2B or mass market, but also for wholesale customers or B2B customers that can all order and provision their own own VPNs. That's the underlay, what we call the underlay transport, totally agnostic from the actual services you provide on top. The service we provide on top, and it's in the B2B domain, that's built, as I showed in the last slide, based on SD-WAN technology. We are now building on a whole portfolio of secure SD-WAN services, as we see that there is a large need for secure services, especially in our business SME domain. That's for the service part. In the technology, we changed a lot. We decided to move away from MPLS to segment routing v6. Main reasons were scalability issues with MPLS and also the complexity of the protocol stack. So when we build new, then with the latest protocols and it's SRv6, this will all be fully in operation in 1 year from now. It's already in operation, but we're now currently onboarding different networks. We also move further away from IPv4 to IPv6. As a matter of fact, this whole underlay network is based on IPv6. The only exception we still have is the multicasting in the underlay. We're still looking for a proper protocol to do multicasting over SRv6, but as soon as that will exist, then we will move to that protocol. In the access technologies, we said we put on 10 and 50 gig PON. Today we provide 10 gig, and in the future we will move. We're preparing now for 50 gig PON. In the mobile domain, 4 and 5G, and we will phase out the 3G access by the end of this year. And also in the wireline domain, we move away from copper infrastructure, but it will take a little longer than the end of this year before we get rid of all our copper. Now, what is also important is this last part is you can build the best network or the best network architecture in the world, but that doesn't guarantee you to have a good availability of your network. You also have to have a look at the way you operate this network. And for that, we introduced the CI/CD pipelines. I'll get to that in the next slide. And we prohibited our operations to further use command line interfaces or building scripts that trigger the command line interfaces. Everything we do on this network is fully automated in the CI/CD pipeline. Also, with this transformation, we had to change and renew completely our OSS infrastructure. We are putting on the Open Digital Architecture framework from TMF. And we had to change our organization into a DevOps organization where our teams build the IT to steer the network and also operate the network. So these are basically the same people. Now, I get to the last slide about CI/CD pipelines. We got that idea, as many ideas, from the cloud. Here above, you see how Red Hat implements CI/CD. So it's basically delivery micro releases in a completely virtualized environment. And we have copied that same concept to develop our networks. So you see here in the black boxes different stages of our labs. Here I have 4 stages. These are actually 5, where we with full automation, we start to develop new services on the network. You go from the development stage, an isolated lab. By the time you're finished, you can go to the integration stage. But first you have to pass a whole suite of automated tests. These are, meanwhile, a couple of thousand tests we run to see if that new development is fully compliant with the network. And only if you have passed these tests, you can go into the integration state. You can test your integration with the complete network and the surrounding systems. You get again into a circle of full automated tests, and you get into staging, and from there we're pretty sure it will work in production, and in the last step you get into production. And this part, this automation, is the first step towards what we also want to automate with AI technology. So we're now working on AI assistant development that also supports us once in doing the developments based on specifications of the network equipment and the specifications of the services, and then verify these developments into the network. Okay, with that, I get to the end of my presentation and hand back to the moderation. Thank you.
Okay, so thank you very much for Bram's presentation from Swisscom. So we are going towards the last section of the presentation. So here I would like to have the poll with the audience. So audience have a chance to poll and give the vote so we can see what about their understanding. The quick question is, do you think WBBA introduced Net5.5G foundation architecture will helps you in your end-to-end network modernization in AI era? A, yes, it will help and guide us. No, it is not. Number B, and the last is not sure now, but open to discuss and consider with the WBBA team. So you can choose one of them, and then we can show the live results of this poll after this question in 30 seconds. Okay, so I think we are moving towards the results. Let's see the findings. So 66%, we call 67%, yes, it will help and guide us, the Net5.5G foundation architecture in end-to-end IP network modernization. No, it is not, 0%, and then 33% not sure. So I'm more happy to see that 33% mentioned they are not sure, so they want to discuss and explore further for Net5.5G architecture modernization, what we already presented here. And I think that's a good result. So we can consider this one and discuss in our next meetings. And we're welcoming you guys as well to log in and register on WBBA website and become a part of the WBBA group, and then contribute your contributions from your network side. So the last slide, the conclusion of this webinar, we're trying to close this now. That number one conclusion is that WBBA Working Group 4, the all aim is to demonstrate a technical leadership in the industry for IP transport network or datacom network modernization, and make it a reality and happen for service providers to follow and then brainstorm further to become a monetization for in the AI era. Second, the whole telco industry should calibrate, is not only WBBA, and we believe that if we all telco industry, including vendors and service providers, contribute and collaborate towards this modernization through Net5.5G, I think it would be grateful and quite helpful for service providers and telcos in AI era. And last but not the least, Net5.5G use the native SRv6 IPv6 technology as the core protocol for packets from access towards the data center. So these are three messages. We do have the questions I have seen, but because we are running out of time, I think we already 10 minutes late as per the defined agreed time of 1 hour. So you're more than welcome to see your answer, your questions to us through email or WBBA platform, and we can ask our panelists to answer that one. So thank you very much for your presence, and thank you very much for your time. I think it's really a nice webinar in a way that real industry experts share their opinion, insights, and viewpoints about their real network modernization in their companies. So thank you very much, and bye for now.